That's okay. No.
They're just gonna have sailor moon is physics. I mean, it's astronomy.
Minus 9.
I don't want to worry about them. No. They really.
Like,
Here's a little beer garden. Oh, really? Oh, really? You're right. Wait, is there a, like,
no, but I was talking about starting.
And then I started, I like laughed. I went to like these two workshops.
I don't know how exactly. How do you get like the general public to say the first time? You're right, but do you think they want to learn about the pure science outside of school?
It is 11:46.
And my friend coming down here, I was like, I really got the time to be friends. So I really know.
Like my stove is like 7. No, it's not going to get a rip until I never clean it. And the reason why is when I work on it, right? Like it's weird to me that I just like to have it constantly checking the because it's like this minute glancing clock. So what I do is I break this habit by just not checking the time. That's it.
Why don't you want to look at the clock? Like sometimes I just want to know what time it is, so I can get to the bus.
And then I check the clock and I know it's accurate. And I check my computer clock knows accurate. So I can literally check the clock. But what I don't want is when I just around the house and just kind of like killing time. Oh, what time? What time? What time? You know, like.
But then you do that thing where you stick around for too long and then you miss the thing that you're
I never miss anything. I have so much anxiety about being late.
I do too. I
Between,
have
like-
to be ridiculously early.
Yeah. Between like school and the army and like everything, like I show up places 15 minutes early and just sit in my car. I just listen to a podcast like that, you know?
She did sleep with the note. Yeah. Okay, good.
A nice breeze coming in here.
Yeah. That was a B.
Is this Megan first?
That's Megan
Yeah,
first.
sure it's Megan.
I swear.
This
It's a business card. Yeah. Oh my god, it's so cute.
I got her this name. I am like in order.
Yeah, but like, the light is on.
I've seen some memes about this.
Talking about business cards just like puts me in Megan.
Yeah.
These are so nice. I love this.
If you want to get business cards, I got her deals from some business cards. It's a small print shop. It's like a local business. They'll make you a custom design. They just make you whatever you want to design.
It's a nice
They
tool,
save
too.
exactly. They save the print on it. So you get 10% off reorders. So if you guys want to find, I'll give you my discount code.
I have to clean up my website before.
I'll make you your website if you want.
Can you? I have one
Dude,
that's on
okay, hold on. Hold that up. Hold that up. Look at the URL at the bottom.
Yeah,
Look at that.
nice.
Do you see the URL?
Yeah, I see it.
I own that for like 3 years.
Oh yeah.
$36 a year. Okay, go to Google Domains. I bought DanielRohana.com, Rohana.tech. So I also have to email Daniel@Rohana.tech,
Hell yeah.
which is great as a software engineer.
Like someone's gonna see you talk to you.
There's
nothing on the website. So if you go
Testing,
to it,
testing.
it's on the domain.
Testing.
Yeah, like you want to buy your name domain. You know?
This is such a like this though.
Really?
Like I think like this if you went back in time and you were like telling fucking Victorian person about this. This might put that up.
Okay, perfect. Yeah, but if you also went back there and showed them an iPhone, they're fucking losers.
But like
Good.
fair.
Look at this glowing book I have in my pocket. Talk to
I
somebody.
think like now we're all about like planning, finding like our self and so we can like have
Yeah, it's self-modification.
yeah,
Yeah.
exactly.
Yeah.
Yeah, do I even wrap the part?
Yeah, you bring up an interesting point. There's a lot of like for self-alienation, but at the end of the day, like some degree of alienation is good. You know, you need some kind of like results of
Yeah.
The last thing you want is to every day have like a meeting. Like, how do we give you a couple dollars? How do we give up everything? How much electricity is going into it?
Megan, are you speaking? I guess I'm hearing the first part. Yeah. Thank you. Thank you.
They got 60% yesterday. Yeah, my partner.
I mean, this is a lovely game.
I think today's Angelle too. Are you keeping the same name?
Fuck yeah.
Hell yeah.
You're all computer science. You're all computer science.
Oh my god! What are you saying, man?
Why would I just say you put it on me? I put my money where my mouth is. At least 6 out of 7. That's not best before.
That was good.
It's actually, that's not a 7.
No, I think I remember that one. Yeah.
I know, I'm so chuffed. Shit, where's my PhD?
Yeah, I heard it. Yeah, this guy did a Parker grant.
You know who they should give an honorary dog girl to? That dog who the meteor fell through the roof in.
Yes, they should. That guy
They
is
should get an
good.
honorary
I have a
dog.
lot of fun. Yeah, you like this? Yeah, I'm always fun. Normally we have like public
Yeah.
it made me have to pay attention.
Normally I really just like
I'm so out big time.
the only reason I'm able to play piano all this week was that my exercise taking notes. I like forced myself to like kind of out. Should I start hitting on trivia stuff?
yeah, and so I got a free coffee because the morning barista, Joey, couldn't get the music working. And he was like, I'll give you a free coffee for pictures. I'm like, I am a computer scientist. All I did was flip the iPad around, update on the App Store, and it worked. And he was like, you get free coffee.
I don't know.
That's who wrote the honors. Yo soy Isabel.
Yeah. I'll be home, but I'm not doing anything other than just praying that something happens in my life this afternoon because I really just want to be here.
February 8th.
Yeah. Yeah. When I put it in my wallet, it's gonna lose it. Do I want to? So, okay, so cross-country driving, yeah, cross-country driving, I could probably do it. But last time, I like to meander in the Colorado or something. I
right here.
Chug. You guys just have one microphone? No, you'll be fine. Like, I'll hold it between us while you do the news bit.
Okay.
You want trivia sheet?
I already got one.
Okay.
Is it cheating if we're astrophysicists playing trivia?
Angelle is speaking first, right?
That's okay. My
I
girlfriend
think
makes
so.
the questions.
It doesn't always mean you'll get it right. Yeah.
No, look, I want to win this for the love of the game. Yes, yeah.
That's healthy competition.
Not if you grade on a curve.
What's the curve like? What's the curve like? Like,
I don't take population statistics here.
What if you're rating on like how good your handwriting is?
Oh, I would crush. I have Asian girl handwriting.
not
Oh,
basic.
like the bubble letters?
Yeah, no, like literally, when I'm not scrawling, I have very, like, this is a little bit of a, like,
That is Asian girl
I
handwriting.
know, I'm not joking.
I would assume that was a woman.
I know, maybe I am.
Is there a reason why it's facing this way?
I tried to give this to her and she walked away from it.
Hey, trivia? Trivia?
Oh, trivia.
Oh, yes.
Yeah, right here. I don't have a pencil for you though.
Are you going to be standing on this? Right. Are you going to be on this side? Yes. Can you look at the viewfinder? Is this better? Which way? Oh, okay.
Dumb question, why do you put it in the middle?
They don't pay me for this.
What if you ran it above this? Yes. Oh, he's a second. Here, watch that on the cups. Watch that on the cups. Crazy. I'm sorry. It's part of my charm. Okay. I'm just running. More? Up?
Sam, do you want me to announce while you're talking? Yeah, and I'm gonna run to the other side to see if anybody wants.
I got so scared and how people over there that I front half happening, so we're gonna have Sam do it.
Okay, so you announce and then I'll run to the Wait, Sam, do you want to wave? Okay, everybody, we're gonna get started with Astro on Tap in just a minute. This is your final reminder to get a trivia sheet from Sam if you want to play trivia with us. Thank you.
If you're within the sound of my voice and you're not over here to watch Astronomy on Tap, this is your final warning. We're going to be having some awesome astronomy talks. So if you're a fan of astronomy, also if you're a fan of trivia, we're starting trivia. So now's your last chance to get in on the fun.
Am I going over there?
He calls her out of his phone. I know, but that's what you want.
Have you seen this trivia?
Yeah, Sarah, hey.
be here real quick before we start.
I just want to make sure they finish their should I wait for your tape to start? Oh yeah, Emily just came over. Will you hold up the prizes?
Yeah, they like my band of white.
Yeah.
I need people to know that I'm because when people look at me, they don't normally think.
Hello, everyone. Hello. Hi. How's it going? How's everybody doing tonight? Good? Thank you.
Thank you.
Welcome to Astro on Tap. This is our second Astro on Tap of the week. Hello. I don't know if we're going to get... Thank you. Thank you. Okay. How many of you were at the American Astronomical Society conference this week? Nice. Nice. That's great. Okay, so once again, welcome to Astro on Tap. This is Tyler Gordon, my co-organizer.
And this is Megan Duluth, and my co-organizer.
And together we are organizers of Astro on Tap. Good job. So we are going to begin with trivia tonight, and then we are going to move on to our talks for the evening. We'll be beginning with studying exoplanet atmospheres from the moon with Dr. Angelle Tanner. And then we will move on to a bit about astronomy in the news. And finally, we'll finish off with a talk from Dr. Isabel
Rebollido.
And she will be talking about exploring alien comets. Okay, so how this is going to work, we'll have 10 trivia questions. I will put them up on the screen for 30 seconds apiece. And then I will go back through all the questions for only 15 seconds apiece. After we're done with trivia, we'll have everybody turn in their trivia cards to us, and during the first talk, we'll grade them. After our bit about astronomy in the news, we'll announce the trivia answers and winners. And then when all of the talks for the evening are done, we will hand out the prizes. Okay, so without further ado, let's get started with trivia. So first round, you have 30 seconds per trivia question to write down your answer. Thank you. Oh, and I want to mention our prizes this evening are sponsored by Starchive. So our first place prize is going to be a tote bag, which is fantastic. Yep. A Hubble image of the pillars of creation is on this bag. Our second place prize are going to be a set of 2 glasses with the Artemis mission on them. That is going to be NASA's next mission to the moon. And our third place prize and beyond will have their choice of calendars, frisbees, and stickers. So we just want to thank Startorialist again for sponsoring our prizes tonight. Almost forgot. I'll just give this first one like 10, 15 seconds. How to for so long.
I'll eat the shade.
You should know this one.
Yeah.
I said it in my talk today.
You could also count the plants on the photo that I made for yesterday.
That's true.
Oh, we missed one.
What did you say to number 5? Oh, I should have gone to the bouncy house.
They go with an interesting choice.
I think it's
Burnt okra.
I was in the ballroom, so it was kind of scary, but I knew it was so cool.
Oh, wait, no, that's not what you did.
I really like that photo, actually.
Okay, I hope you got your trivia answers down. But if you didn't, I'm going to go back through all of the questions for a shorter amount of time, 15 seconds apiece, and then we will move to our first speaker.
I think I enjoyed it more when I was anything in baseball.
But the third wins it. Sam, are you ready to play? Yeah.
All right, everybody, we're wrapping up our trivia here. We just ran through the slides twice, so if you missed any of them, that's on you. We're going to have you go ahead now and bring your trivia sheets up to the front. Sam up here, who's waving her phone around. Sam's going to collect your trivia sheets, and very importantly, your little tiny golf pencils. If you have one of those, bring it back up. We have no funding, so we can't afford to buy more pencils, so please bring those back.
There's 2:30. Gabby.
Yeah. There's like so few.
There's
To me, you're all the same person.
All right, now's your last chance. If you didn't bring us your trivia sheet or your pencil, bring those on up now so that we can grade them. We're going to be announcing the trivia winners after the second talk. All right, it looks like we've got all the trivia sheets. So, with no further delay, I would like to introduce to you Dr. Angelle Tanner, who is going to be talking about studying exoplanet atmospheres from the moon. Yes, give her a round of applause. I was going to tell you to give her a round of applause, but you started it before I even told you to, so that's great. You're all very friendly. All right, so Dr. Angelle Tanner.
Is this mic on?
Let me
Do I
get.
even notice that if it is?
Is the mic on?
Am I set up?
Mic
My
good?
mic's on?
Yes.
Okay,
Yeah,
cool.
you're good.
All right. Hello, everyone. Thank you for coming out tonight. Especially if you were at the AAS. I know it's been a long week. We're all tired, but now we can sit back and chill out and have some fun. All right. So, do I have a slide advancer? I do.
Just sit here.
That's that thing. Okay, cool. Okay, so I am the science PI of a mission that we're working on called Luster. And basically, we are going to be putting a telescope on the moon. Where do I point? I point over there. Point up there. There we go. I don't know what happened there, so I'm going to just talk. That is so weird. What I wanted to say is that this is part of a collaboration between, I'm at Mississippi State, and then we're actually working with astronomers at LSU, and we're working with SETI, and so it's the collaboration of a whole bunch of people at lots of different institutions. So that'll be fun. Okay, why do we want to go to the moon? So the main reason is because the moon, unlike Earth, doesn't have an atmosphere. So that's very useful. So when astronomers use telescopes on Earth, we have, if you go outside when it's clear here in Seattle, which is very rare, I know, you'll notice that stars, they twinkle. And that is the Earth's atmosphere causing the stars to do weird stuff. So astronomers don't like that. That's why we send telescopes into space. But we could go to the moon and also not have an atmosphere. So that would be very useful. And then also, unlike space, where you're just kind of floating around in space, if you put your telescope on the moon, at least you're going to have your telescope sitting on something that's actually stable and actually rooted into the ground. Come on. There it goes. I don't know, is it the laptop maybe? It's wherever the USB port is. What? It's the laptop. Okay, there we go. It's also very handy because if you think about it, and my students have to think about this a lot, and I had to think about this a lot, you don't have to worry about looking at during the day and looking at night and then looking at the day. So we're going to have 2 whole weeks of straight observing of looking at our objects, and that's useful. There it goes. And then we're also super excited. The one thing that we're really going to motivate us to put this thing on the moon is that we're going to get a free ride. And I'll explain why. That's really motivation. In the end, it's always about money. So we're going to get a free ride to the moon, and it's going to be very handy. And I'll explain why we get a free ride in a second. Okay, so you would think we would have thought to do this before, but we kind of did. Back in the 70s, we actually did put a telescope on the moon. And we did that by handing it to a bunch of astronauts. Back in the day, they actually, landed on the moon for real. It wasn't fake. And they put this gold-plated, so clearly we had lots of funding, special telescope on the moon, and it observed at ultraviolet wavelengths. So I'm going to talk about ultraviolet a lot. Whenever you're out there on a sunny day and you have to put on sunscreen, I know, not something you do here that often, but it's that ultraviolet light that you're trying to protect yourself from the sun. So that's the same wavelength of light that this telescope was observing at. But the Earth's atmosphere blocks a lot of this light from us and protects us so we don't keep getting, melanomas. But on the moon, we're able to observe at ultraviolet wavelengths. And so this is an image of Earth taken in the ultraviolet using this lunar telescope. And then later on in 2013, China also put a telescope on the moon, but that's been it. We haven't been putting any other telescopes on the moon since then. And so now, you may have heard, we just heard about the Artemis finally launched, and it did an uncrewed mission. And so now NASA is spending a whole bunch of money to try to get humans back on the moon. And in order to do that, we're going to have to land a whole bunch of uncrewed landers. We're going to want to put supplies on the moon. And this is a very tech-savvy city. You guys know there's lots of contractors out there and lots of aerospace corporations. And so they're already bidding to land various landers on the moon. And so there's going to be a whole bunch of things being sent to the moon over the next few years, getting ready to send humans to the moon. And so we realized, well, we can just hitch a ride with these guys for free, at least pretty close to free. And boy, do we like that. Free is always good. And so where are we going to go? You may have also heard that we've discovered water on the moon, which apparently is a big deal. I guess we didn't think we'd find something like that on the moon. But if you're going to be sending humans to the moon, it sure would be nice to not have to bring water, right? We sure hate to have to buy water. I always get annoyed that I got to carry it up the stairs because it's so heavy. So if we could land somewhere where water already is, then that would be great. And so we don't know where we're going to land our lander yet, where our telescope's going to be, but there's a good chance we'll probably catch a ride and land it near where the water is, and that is going to be an area of the moon called the Schrodinger Basin. So that's something we're going to be looking to. Oops, that way. Can I do it? No. Oh, here, I did. So we already have the telescope kind of designed. It's not built yet. We're still working on that. But this is the telescope. I might have a laser. Maybe that's going to be the on-off switch. That's okay. But this is the telescope, and it's kind of almost, it's a lot like a telescope you might actually buy and use in your backyard. It's going to be about 15 inches in size. And that's the whole telescope. It'll have an ultraviolet camera on it. So I mentioned ultraviolet before. We're actually going to be observing in ultraviolet too. And then it's going to have a basic mount. So it's going to go up and down this way, and it's going to rotate this way. But we're going to have to invent something called a lunar clock drive, because we've never put a telescope on the moon in a while. And so we're going to have to invent some stuff, and that'll be nice, because then if we ever want to put more telescopes on the moon, we'll know how to do that. So that'll be kind of cool. But if you think about it, it's a little bit different to track stars from the surface of the moon than it is to track them from the surface of the Earth. So it's kind of cool. Okay, so why exoplanets? Well, exoplanets are cool. We've discovered over 5,400 extrasolar planets in the past few years. When I was a grad student, we didn't know about any of them, and now we've got thousands. But this image is kind of showing you a collection of extrasolar planets, and this image is kind of a lie, because we don't get images of extrasolar planets like this yet. Oops, oh my goodness. What happened? It's stuck. Can someone get me some water? Some water? So we can't quite get images of extrasolar planets yet. Anytime all these press releases came out this week because of the meeting, and a lot of the press releases had these really cool, I got a thing over there too. Oh, thank you. And all the press releases, they always come with these pretty cartoons, but this is not what astronomers see, unfortunately. We just don't have the technology to be able to collect these pictures yet. I mean, we're working on it. We want to have the technology to take pretty pictures of planets, but we're not quite there yet. And so, but we want to study the atmospheres of these planets, because we want to eventually know whether or not they would able to sustain life. They'd be able to sustain life. So that's pretty cool. We're looking into that. So we're focusing on a very specific subset of planets, and these are called transiting planets. These are planets that over the orbit of the planet around its star, it will actually pass between Earth and the star. And so a planet will actually block out the light from the star and make the light go down, and then it goes back up, and we call that a transit. And that's been the most popular method to find extrasolar planets. We found a bunch using something called Kepler. We found a bunch from the ground. And now we're using the TESS satellite to discover lots of these planets. And there's something special about transiting planets. And here's another image showing the kind of data we might collect. If we observe a star and the planet's going to transit, this is what it's going to look like. We'll see the light being flat, and then it'll dive down, and we'll know that the planet's transiting. The special thing about transiting planets is that if we get transits, at different wavelengths of light, and we put all that information together, we can actually get the spectrum of the atmosphere of the planet. So as the light travels from the star, it will pass through the atmosphere before reaching the Earth over its transit. And so you've been seeing all these results coming from JWST of WASP 39, and you'll see a whole bunch more results coming out soon over the next few years. And you'll see that it's you end up producing a squiggly line like what's over there, and that is an exoplanetary atmospheric spectrum. And from that, we can tell the pattern of the lines tells us what molecules are in the atmosphere of this planet. So we have discovered water, carbon dioxide, and methane in the atmospheres of alien planets. Okay. So here's some other spectra just showing, these are all squiggly lines, showing you that they all have different features to them, and depending on the pattern of those features, it tells you what is in what molecules are in those atmospheres. Now, right now, this is the only way using transit spectra that we can study planets that are smaller than Jupiter. So we don't have the ability to take pictures of planets that are smaller than Jupiter orbiting other stars yet. We will in the next few years, but right now, transits are the only way that we can study the atmospheres of these planets. And you'll see a lot more about this in the coming years. And so with our little mission, I wish we were going to do it with all that data that JWST gets, but from the moon, we have to start somewhere. And so what we're going to do is we will just get, the mission's called Luster, and we're just going to get one data point at ultraviolet for the transiting planet. But that's still very valuable because it's going to be a very small telescope, only 15 centimeters. And we can't get this data, it's an ultraviolet data point, and we can't get that from the ground on Earth. We have to use the Hubble Space Telescope if we want to get that kind of data for these exoplanets. And then I can tell you, having served on the Hubble Space Telescope Allocation Committee, that it's really hard to get Hubble Space Telescope time. So this will allow us to get a whole bunch of data points. It's just going to be 1 point, but at least it's something at the ultraviolet. And if we get a 1 point in the ultraviolet and we compare it to the point that we can get in the optical from Kepler and TESS, then even just knowing the slope of that line is very valuable. So, and notice that over there's some Hubble data and some Spitzer data where you get to see all the patterns and you see bumps and wiggles from the molecules in the atmosphere. But notice over towards the optical and the UV where Luster is, everything's flat. Well, that's because of something you're quite used to here in Seattle. That is due to atmospheric haze. And it's been frustrating to a lot of astronomers because they get all this data and then they have a flat spectrum and it doesn't tell us much. You can't tell what molecules in the atmosphere if it's flat. But it still tells you some of the physics of what's going on if you even just get that slope. And so we'll get one data point from Luster, one data point from Kepler and TESS, and that'll help us out a lot. And it's from the moon, so that's pretty cool. All right, so we'll be able to tell whether or not the planet has an atmosphere or doesn't have an atmosphere, and that'll help tell JWST what we want to do with that telescope. Another telescope where it's really hard to get time on. So knowing as much as we can ahead of time is very useful. Okay, so what does this mean for the future of the moon? We've been thinking about putting telescopes on the moon for decades. This was kind of an old 1960s cartoon I found. I mean, the moon is very handy because it's got these crater shapes on the surface that look like telescope dishes. So we've definitely been thinking about it for a few years now. And the radio astronomers, they've really been thinking about putting telescopes on the moon because all of you are holding on to your iPhones and you're all emitting you're emitting signals at radio wavelengths and microwave wavelengths, and that's screwing up all these radio observations that we're trying to do from Earth. So the radio astronomers, they really want to put telescopes on the far side of the moon so we can use the moon to block out all that radio emission from us pesky humans. And we already know how to do that because there's an image of Arecibo before it collapsed, and it's conveniently it's a shape like a crater. So we already kind of have a skill on how to do that. So I did find out that some people are thinking about putting optical telescopes on the moon. I mean, this is going to cost a lot of money, and maybe not do it next. Maybe our kids or our grandkids will do it. And it's pretty cool because they actually said in the article that they're hoping that maybe with these transiting planets, we'll actually be able to look for exomoons. So we could look for Endor or Pandora, or rings around the planets, or even based on the shape and the properties of that transit, that dip, we can even look for mountains on the surface of the planet, which is pretty crazy. But you need a really big telescope to be able to do that, and a really big telescope with no atmosphere. So that's where the future is. But this is probably decades away. We just need money. We know how to do it. And so that's it. We're doing a telescope on the moon. This is still weirdly messed up. But I handed out your moon pies. This is a southern delicacy. Would I really call it that? I guess. But here's the actual logo on here. And keep an eye out for the Luster program. Hopefully going to launch. We're hoping and aiming for 2027. All right, thank you. Oh, are we doing questions? Do we have time for questions or not? All right, questions? Do you have a roaming microphone? Oh, I can repeat the question. What? I have to what, people? What? Oh, when the question was when it will launch. We are aiming for 2027. So it's not a really big thing. We just have to get on to one of these lander missions. As always, depending on funding, right? Question? The question was, how does the haze smear out the features? That's a good question. Well, it just makes the atmosphere more opaque. So imagine you're putting an opaque piece of glass in front of your neon sign, and so you don't see the features anymore. Yeah. Sometimes you can see sodium and potassium, but you can't if it's too hazy. My ear, it's really close.
Since the moon doesn't have an atmosphere, what about like collisions on the moon, like impacts on the moon affecting anything we put up there?
It's an excellent question. Yeah. Okay, she asked an excellent question. I get this question all the time, and you're going to even hear a joke about it in a second. So she asked, what about collisions? So yes, this is a test mission. This is one of the whole reasons we're putting this telescope on the moon, is to also understand, like, what are you going to do when you land and you're going to kick up a bunch of lunar dust, or maybe a micrometeorite comes by and crashes near it and the dust gets knocked up. It's going to have baffles around it to keep the dust off, and we're going to have to also make sure that the light from the surface of the moon, because we're actually observing during the day, I kind of ignored that particular detail because it's got solar arrays on it. And so in order to keep the power up, we'll actually have to be doing it during the day, which is very unusual for astronomers. We usually do it at night. And yeah, so there'll be all these baffles and stuff to protect it from the dust. But that's what we're testing out, the technology we need to protect these things. Yes. Yes, over here. Well, it'll be on the moon forever, right? But we'll be, unless we don't pick up our trash. Right now, we're gonna be observing for 2 weeks. But if we can get the batteries to last through the night, because it's solar powered, then we'll keep observing 2 weeks and 2 weeks and 2 weeks until the battery dies. So, as long as we can get away with is really what we want to do. Other questions? Pardon? How much? Oh, you're asking that? It's not polite to ask how much a mission is. I honestly don't really understand. I don't know, because we're paying for little bits of it. I know that we're applying for $10 million from NASA, but we already have a couple million from the Gordon and Betty Moore Foundation. So we're getting funding from different places, and I have not been told how much this whole thing costs. Yeah. Go ahead.
Develop your lunar clock, or do you actually have to wait until NASA picks the location?
Oh, that's a good question. That's an excellent question. Yeah, that's a good question. She asked, do you have to wait for NASA to pick the location before we develop the lunar clock? I think the way the design looks, the clock's mostly software, because it's what we call an alt-az telescope. So I think that's mostly just going to be a programming issue. But I'm assuming whether or not we launch on the equator versus the pole might infect the hardware. So probably a little bit of both. Come here. You can't. I don't hear well in crowds. Yeah.
The telescope on the dark side of the moon, how would you get the data back to Earth?
That's an excellent question. The telescope will not be on the far side of the moon. You have to be careful, because the moon, the dark side of the moon, if you really think about it, the dark side of the moon changes with lunar phase. And the astronomers have had to think about this. It's going to be landing on the same side of the moon that always faces the Earth. So you have a direct line of sight. The data will go from just like the astronauts. The astronauts were on the side that faced the Earth. Yeah, so it'll be on the near side of the moon. So the data will go straight from the moon to the Earth. Any other questions? These have been great questions. They're getting me ready for Congress. This is great. Well, it's traveling at the speed of light. So how long? Huh?
Last question.
Last question? I don't know. Any astronomers, what's the light speed time to the moon? 8 seconds? Is that right? 8 seconds? I know it's 8 minutes to the sun. No, looking at it? No, just kidding. A few seconds. Yeah. Okay, thanks everybody. You've been great. What?
This table out a little bit and put a few benches behind it.
Yeah, can we move this out? Or can we move this at all? Okay, all right.
All right, everybody, another round of applause.
Thank you.
Former Wildcat?
What?
Former Wildcat?
Yeah. You look familiar.
Yeah.
Who are you?
You were in grad school when I was a grad student. Because you were in Megan Sosie's class, weren't you?
Yes. Oh, so were you in the same class as Chris Godber?
I was a couple years ahead of Gokrat.
Chris, he's actually married. I'm at Mississippi State now. He's married to someone at Mississippi
Laura is
State.
a professor at Mississippi State like you. Yeah, I know. I know Laura well.
Yeah, so I went and visited. I went to a party at their house, and I'm looking at the textbooks going, these It'll be, you'll see. This is a little skit we do whenever we do Astronomy on Tap, so I hope you enjoy it. Okay. Okay, I'll start with the song. Ready? Hello, this is Susie Saturnalia.
And I'm Vega Andromedopoulos, and this is Astronomy in the News.
All right, come on. There it goes. All right. This week, 3,400 astronomers descended on Seattle for the 241st meeting of the American Astronomical Society.
When asked, why on earth would you have an astronomy meeting in a city famous for being cloudy, AAS officials replied, we figured if the astronomers don't need to stay up all night looking at the stars, they might as well drink a lot of coffee.
Pause for laughter. Yeah, I know. All right. At the meeting, they announced the discovery of a new Earth-sized planet orbiting in the habitable zone of the star, TOI 700. The star lies at a distance of 100 light years, so any aliens on the planet will decide whether they want to invade or give us warp speed. Come on. Timing is everything when you're doing improv. No, it's just being picky. All right. They will decide on whether they want to invade or give us warp speed based on their taste for the Charleston. Da 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 da. All right.
In extragalactic news, astronomers have used JWST to see galaxies, which are surprisingly fully formed when the universe was just 300 million years old. This is equivalent to a human being fully formed at the age of 2.
Fully formed, the only thing I've seen fully formed from a 2-year-old is a nasty surprise in their diaper. Right.
Hey, up here, astronomers are trying to put a telescope on the moon.
Oh, well, yeah, I just talked about that at the meeting and just a minute ago. You were here.
Well, I wish you guys good luck on the mission. I hear it's going to cost a lot of cheddar.
Ah, come on. Thank you. Thank you. Cheddar, oh, I get it. Because they're going to the moon, that's really funny. Ha, ha, ha.
So, are you worried the telescope will get covered with lunar debris? Get it? The debris?
Ha, ha, ha. Oh, have we had enough moon jokes yet?
Yeah, that's good enough.
Okay. Okay, on to space news. Come on. Thank you. On to space news. The OneWeb company just launched another 40 satellites into space, thus adding to the hundreds launched so far by SpaceX. Boo! With plans to put 1,000 more satellites into space, into low Earth orbit, astronomers are fearing for the future of ground-based astronomy and our ability to enjoy dark skies.
Well, I guess you'll see me working at Blockbuster very soon.
You know, there is no Blockbuster anymore.
How about Sears?
Nope.
Pier 1.
Nope.
Bed Bath & Beyond.
You might want to check the news.
Okay, I guess it's back to grad school for me then.
That sounds about right.
Back to new astronomy news. We have discovered a new, hot, young planet around the star TOI 2206. Planet B is just 0.01 AU away from its host star and has a surface temperature of around 4,000 degrees Fahrenheit. Wow, that's hot!
Yes, and we have yet to discern whether the system has a colder, older planet seeking alimony and maybe a tummy tuck. You might want to get out from these city lights. Come on. Advance. Thank you. You might want to get out from these city lights and catch a glimpse of a new comet in the night sky. The comet named, yikes, okay, C2022 E3ZTF will appear green in color due to the oxygen present in its nucleus. It is believed that the comet last visited 50,000 years ago when Neanderthals wandered the Earth.
When asked to describe on the splendor of the comet during its last visit, a witness replied, "Ugh, comet pretty, and Earth not good, not end good."
And finally, for the first time that I know of, the AAS featured multiple sessions on detecting alien technosignatures. These are signals from alien technologies like laser pulses, Dyson spheres, or electronic transmissions. One of the sessions revealed that the problem might be that aliens have been contacting us for the past few decades, but the messages have been stuck in our junk email folders. Thanks a lot, Microsoft. This has been Astronomy in the News. I'm Susie Saturnalia.
And I'm Vega Andromedopoulos. Stay tuned and keep looking up.
That was okay. The delay was a problem.
Okay, good job.
Thanks. It's hard to do it in this environment. My God.
And I'm going to stand over here. All right. Number one, how many planets are in the TRAPPIST-1 system? Is it 6, 7, 8, or 9? And the correct answer is 7. Although I know a few other people who would say that maybe there's an extra one. We're not quite sure yet, so maybe this answer will change in the future. But for now, we know of 7 planets in the TRAPPIST-1 system. Shout out to Eric. All right, number 2, which astronaut is famous for having written his daughter's initials on the moon? I'm realizing now that it's a little bit hard to see the correct answer here because it's marked in red and it just doesn't show up great. But the correct answer is Gene Cernan, who I believe was the last man on the moon as well. Is that right? Number 3, which are the most common types of galaxies in the universe? Spiral, lenticular, elliptical, or irregular? And the answer here is elliptical galaxies are the most common type of galaxy in the universe.
Like, I don't know which, yeah.
How far away is the nearest star that is not the sun? It takes 4 years for light to get from our nearest star to the Earth. It is 4 light years away. Who was the first female commander of the International Space Station? That is B, Peggy Whitson. What color is the sunset on Mars? It is blue. Apparently, I did not know that one myself. I probably would have said red for obvious reasons, but it is blue. All right, you got a little preview there, but I'm still, you know all the answers now, but I'm still going to announce them. All right, which planet has a hexagonal-shaped storm? The answer here is Saturn. Might have thrown you off because you can't see the rings there. I'm willing to bet that a lot of you put B, Jupiter, because that looks like Jupiter to me. That probably would have been my guess. But that is actually Saturn with the hexagonal storm. What is the appearance of a comet called? Is it an emergence, a pageant, an apparition, or a manifestation? Unfortunately, it's an apparition. I think B or D would be much cooler, and if I could go back in time and change one thing, it probably wouldn't be this, but this would be like the second thing that I would change if I could go back in time and rename the appearance of a comet. I would call it a pageant. I think that's really nice. All right, some galaxies in our local group are moving towards our galaxy, the Milky Way. Is this true or false? The answer is true. Under the influence of the gravity of the local group, some of our galaxies are collapsing towards each other rather than expanding away from each other. And number 10, how were heavy elements like gold and iron formed? Was it in a supernova explosion, in the Big Bang, when two galaxies collided, or in a coronal mass ejection? And the answer is A, in a supernova explosion. And those are our answers for trivia tonight. So now we have some winners to announce. I'm going to start out by announcing the 3 second place winners. There's a 3-way tie for second place. If you won second place because of the 3-way tie, you're not going to get any of the big prizes. Those are going to be for the 2 first place winners. But if you won second place, you're going to get your choice between a Frisbee. Please wait until you leave the brewery to use the Frisbee. Or a calendar. You can use this in the brewery if you want, but you probably already know what day it is. Okay, and with no further ado, our 3-way tie for second place is Team Jamie 97. Who's Jamie 97? Raise your hand if that's you. All right, good job, Jamie. Grab a Frisbee or a calendar. Take your pick. All right, grab it. There we go. Congrats. Jamie got 8 correct. And also with 8 correct is Team Leo. Raise your hands if you're Team Leo. Nice. I'm just going to bring it to you. Do you want a Frisbee or do you want a calendar? Frisbee. I'm not going to throw it. I would, but I can't. All right. And last but not least, because they still are a winner, is team name, I believe it is IAD. All right. And that's you. Do you want a Frisbee or do you want a calendar? Frisbee. I'm still not, I can't do it. I can't be responsible. Okay, and now for the exciting 2 first place winners. And this is going to be random who I announce first. So the first person I get to announce is going to choose which prize they want, and the second first place winner is going to get the other prize. It's just completely random. These are in no particular order. The first place winner that gets to choose their prize is Noah Singer. Raise your hand, Noah. Yeah, Noah. I hear a lot of clapping, but I don't see you. Is Noah here? All right, well, if Noah's around, he can come claim his prize later. But in the meantime, our other first place winner, who I guess is actually going to have their choice of prize, is Lunar Pie. Is Lunar Pie around? All right, nice. Come choose your prize, Lunar Pie. All right, Lunar Pie takes the tumblers. Okay, and with that, could you change the slides? And with that, we're going to get on with our second.
So the calcium, it's blocking that particular part of the light, that yellow light, and it's generating these very deep absorptions. We call them absorptions in the spectrum. So therefore, we can characterize the elements that are in the surface or in the atmosphere of the stars. So if we take that and we apply it to different stars, okay. we apply it to the stars that we think are cool. And the first one was, one of the first ones was Beta Pictoris, because it has a huge disk. Like all that dust that I was showing before, it's around Beta Pic in a very huge, like way, way, way bigger than the solar system disk. So we can look at those lines that are obscured by the elements in the photosphere of the star, and we see those dips that I was just showing. But in this case, we have like these additional dips that we don't know where they come from. They're not from the star. So if they're not from the star, where can they be from? Okay, not everybody at once, please. It could be from the interstellar medium. So it could be something in front of the star that is blocking that light, like especially this. Or it could be from the circumstellar medium. So it could be something in that disk, in this huge disk, that is blocking the light of the star. In this case, like, that's it. That's what's happening. This disk is so massive. There is so many things going on that is blocking the light from the star. And if you look at this, like this arrow was supposed to show now, you see that there is like these absorptions that are generated from material that is passing in front of the star. But, oh, wait, damn it. Okay, but in different dates. So if you see that every date, it's a different line style, and it generates different absorptions. Okay, so now this plot. So these absorptions are actually generated by stuff transiting in front of the star, but very, very fast. So very, very close to the star. And it's just basically these comets that I was telling you about. So these comets, when they pass in front of the star, start to evaporate, just like in the solar system. They generate a tail that you can kind of see here. Well, this tail, when it transits, it generates these absorptions. This is gas from the comets. These comets are so close to their star, in this case it's Beta Pictoris, that they evaporate the calcium. Calcium is a refractory element. We call them refractory elements when they have really high evaporation temperatures. The temperature for calcium to evaporate is around 1500 to 2000 Kelvin. So it's really, really hot. So it's really, really close to the star. We actually call them star-grazing comets. And I want to bring your attention to something else, that it's this. The first exocomets were discovered in 1987. I was not born, guys. Like, I had not been born yet when they discovered the first exocomets. And mind you, oh, sorry, okay. The first exoplanet was this one. This is an artist impression of the first exoplanet. Do you guys know when the first exoplanet was discovered? In 1995, 51 Pegasi b was discovered in 1995. It had gone almost 10 years since the first exocomet until we discovered the first exoplanet. So we know about the existence of comets around other stars before we knew about planets. Just so you know, because I always hear stuff from exoplanet people. It's like, no, we were here before. Yeah, so comets again. So I told you about the gas. That is this part of the comet, but there is a lot of other stuff coming out of the comet. That it's this tail, that is the dusty tail. Because when you evaporate or when you sublimate a comet, everything comes out of it, like the dust and the gas. So if we can see the gas when we look at the spectroscopy, you remember the Pink Floyd thing? We should also be able to see the dust. Well, we can see it when we look at the light of the star, much like we do with the transits of the planets. But in this case, these transits look funny because we are not seeing a round thing coming in front of the star. This is not spherical. This is not symmetrical. This is a completely different thing. So what we see, and look at the bigger one, I think that's the clearer one. What we see, it's a transit that starts like if it was a planet, because the nucleus of the comet is round. It's kind of spherical. But then as the tail transits, the tail is not spherical. The tail just diminishes as the comet passes. The further you are from the nucleus, the less amount of dust you have from the tail. The smaller is the tail. So we have this decay. Can you imagine the comet like comet nucleus and then comet tail? So were we expecting this? Well, yes. Again, like this was predicted in 1999. It had to pass almost 20 years until we actually got a signal. So yeah, guys, keep up. Like theorists are way ahead of us. this is the list now. We have around like 30 stars. You cannot see anything, but you can come ask me if you need to know about the stars. When we have around 30 stars right now where we know that there are exocomets. So there are a lot of these evaporation processes going on. So are we actually having similar processes to what happened in the solar system? Are we delivering materials to exo-Earth where we could have life? Okay, yeah, so but where is the water? Because I told you about calcium, I told you about the dust, but what we want to see is the water. We want the stuff that can allow life in those planets. So what happens is, again, this is the Pink Floyd thing, but it's fancier. What happens is that we can see this light, and then we go to the infrared, and then we go to the ultraviolet on the other side. But we have an atmosphere on the Earth. And you can see the true emission of the different wavelengths that is just obscured by the atmosphere in our planet. And we should be thankful because this is what keeps us alive. Like, this is cancer here, guys. Right? The atmosphere is protecting us, but it's also preventing us from detecting water in other planets. So what we want to do is just escape our atmosphere. We can see water from the ground and enter James Webb, right? The new favorite toy of all the astronomers. James Webb is already functioning. It was launched December last year, so it's over 1 year old now. And it has this capability of looking into the infrared. This is what we see, more or less, this part. And this is what James Webb sees. It goes all the way to the mid infrared to around 28 microns, kind of. And it has different instruments that can do different techniques, like coronagraphy, that is just blocking the light of the star to try to see what's around the star, like planets. But we also have imaging or interferometry or spectroscopy, that is what decomposes the light and allows us to look into those wavelengths. So James Webb is going to be the tool that looks into all these parts of the spectra that are obscured by the atmosphere. So James Webb is going to tell us if there is water delivery in those systems with comets. We're working on it. Yeah, so it has already told that for one planet at least. This was one of the first images that was delivered from James Webb when, I think it was July 2022, right? Last summer. James Webb delivered a few images that were really cool, but one was this one. And it doesn't look good on newspapers. You cannot put this on the cover of a newspaper, but this is water detection on an extrasolar planet. So James Webb can do it. We just have to push it to do it. But we're working on it. Like Cesar here is working on it. Yeah, so, but James Webb is doing a lot of other cool things. It's looking at disks. This is a disk like the one that I showed from Beta Pictoris. It's just a different star. So we're getting really cool images that allows us to study the distribution, the location of planets, a lot of things going on there. We have also seen the pillars of creation, not those ones, better ones. Sorry, trouble people. We're also seeing very big, deep fields like this lenticular. It's not, yeah, this is like a gravitational lens. You can see, I really like the stars that James Webb makes. It has a really cool PSR. And we can also see nebula and all the features that are going on in the bow shocks. And with that, I would like to thank you all. Cheers. Thanks for coming. Yeah.
Okay, cool.
Yeah, I'm happy to take questions. If you want to ask now, that'll be great. If you want to come talk to me, that's also great.
Could you, when people ask, could you repeat the question?
Yeah. Okay, no questions? That's fine. That's great. Thank you all. Feel free to come talk to me or send me an email, whatever. And thank you guys again for organizing. Thank you guys. Oh, no. I have to give you this too.
All right, thanks everybody for coming out for Astronomy on AAS edition. Let's give another round of applause to both our speakers, Dr. Angelle Tanner and Isabel Rebollido.
Can I take a picture? Huh?
And there is still somebody out there who did not find their awesome trivia prize. So if Noah's in the house, I didn't know. Okay. If Noah's in the house, come get your trivia prize. Otherwise, we'll figure out something else to do with this awesome piece of merchandise from Starchive. My only quick announcement is that we're going to be back in February. We do not know the date yet. That's why we have those little brackets there. But we're going to be back in February. Birmingham, Dallas. So if you want to come out for more astronomy talks next month, then keep an eye on our social media to find out what the date of that event is going to be. We're on Twitter, Facebook. We're also on the Astronomy on Tap website. If you search online for Astronomy on Tap Seattle, you can find our information there. So keep an eye on that space. With that, I think we're going to close out this event. So make sure that you grab another beer and support Optimism Brewing. If you still have room for another beer, we're super grateful to them for having us out here.